Welcome to Paper Session 2A. My name is Mike McConville from the Planetarium down in Orlando, and this is the Paper Sessions all about the solar eclipse. And so we're going to start off today with Dave Dundee of the Tellus Museum in Cartersville, Georgia, with his presentation, Solar Eclipse at Tellus Science Museum.
Laser pointer is top, and which is forward? Okay. Well, good morning, everyone, and hi there. So we've all happy to be on the post-eclipse side, and so we had a similar experience to what probably you guys had, and we started planning a couple of years before the eclipse, trying to warm up everyone on staff that indeed this is going to be a big deal from all the different departments at the museum. And my original plan was to be broadcasting from a remote site. I had picked out Andrews, North Carolina, a beautiful site to broadcast the eclipse from. And I and my AV tech would go up there and broadcast the eclipse to the museum. However, things didn't quite turn out that way. So this is the tale of our eclipse. So I'm pressing my little button here. So what's going to happen here? Oh, Mr. Presenter. So maybe it's spacebar time. Okay. Well, this is wonderful. This is totality. Yeah.
Are you sure it's plugged in?
So, as I was saying, so from the very beginning, there were many meetings from department heads from around the museum, even from housekeeping to the store, to our cafe, security, just trying to get them up to speed about what this event could be. Now, in Cartersville, we had about 98%. And so I was not expecting a huge crowd. I thought we would have a lot, but not huge, because another 40 minutes up the road, you'd be in totality. Why stop at our place? And so we had prepared to have the observatory open. We had prepared to bring the signal into the museum. We had prepared to have small telescopes out, have the planetarium running with demonstrations about the eclipse and what the eclipse looked like and on the moon and out in space and so on. And we had the Bays Mountain Show, totality. So we were prepared to host folks at the museum. Well, about a year out, a local ABC affiliate came to us and said, we want to sign an exclusive agreement with the museum. In fact, we want to sign you, David, as our astronomer for the day, for the eclipse, and we want a 30-day exclusive that no other media outlet can talk to you. And in exchange, they would give us lots of coverage on TV. Their parent company also owned the local newspaper, the AJC. They would give us 5,000 eclipse glasses, and they would give us a lot of coverage. They also said, look, if you sign up with us, our viewership is more than all the other TV affiliates in Atlanta combined. And so, we'll do you right. So the problem, of course, is we depend on the goodwill of all the other media outlets for future events. So, so this agreement we entered with some trepidation. We did sign. Yes, we decided we'd go ahead and do that. And so we signed with our local ABC affiliate, WSB TV, and they installed equipment at the museum so that we could live stream our total eclipse from the total zone. We'd actually travel up with the local meteorologist, Glenn Burns, into totality, and we would broadcast back to the museum and also broadcast directly onto the ABC feeds that they would use for local TV. But we also had the opportunity to be interactive from our eclipse site to our museum. Where were we going to go? Well, they wanted to go to Charleston, and I was a little bit looking at the weather maps, and my buddy Fred Espinac said, you know, you don't want to go to the mountains. It's going to be cloudy in the mountains because in the southeast, in the afternoons in August, it's cloudy. So Andrews, North Carolina was crossed off the list, and I was thinking, you know, maybe somewhere in South Carolina or Tennessee. I wasn't really excited about the coast, but the meteorologist said, nope, in the late afternoon, the winds blow from the ocean. If it's cloudy at all, they'll clear along the coast. Okay, so that was the plan. And so they installed the equipment at Fernbank. At Fernbank, I'm looking at April. Freudian slip. So at Tellus, and they brought out their drones. They did drone footage at the museum, and they were broadcasting that back to TV audiences. So they did a lot of interesting things. Now, we had a 30-day blackout period, remember, and so the local NBC affiliate got wind of that, came up the day before of that contract period, and spent the whole day with us filming B-roll, so they could use it during the eclipse. The local CBS affiliate didn't wake up to the fact there was an eclipse at all until about 2 weeks out, and we said, I'm sorry, you're going to have to go somewhere else because we're exclusive. So there's Glenn Burns in our exhibit hall, helping hold up the Earth. And so here are the eclipse glasses they printed for us, and they had our logo on there and theirs. And so we had 5,000 of those. Our shop ordered 6,000 to sell. We had another 2,000 to give away from NASA, another 1,000, thank you, from SEPA. And we figured that would be plenty of glasses because we're not going to sell out of all those glasses. And we were going to hold back 3,000 glasses for Eclipse Day to give away to everybody who might come that day. We didn't think we'd get anywhere near that many, but, you know, we'd have enough, more than enough. So I'm sure some of you had this sign at your places too. It was unexpected, the volume of people that came and wanted glasses, and when we were sold out, it was like we had killed one of their children, and it was just, you know, just a gnashing of teeth and anguish at our gift shop. But anyway, we move on. Even at home, I couldn't escape it. My beagles wanted glasses. So. Anyway, so the other thing that I was very careful to do before I left, and leaving your home institution, yes, I've trained my staff how to use the observatory and the planetarium, but you think you've anticipated everything that could go wrong, but you're leaving with some trepidation. Here's this huge astronomical event, and you're not at your home institution, so that's a little bit nervous. So we actually had a day where we had a whole mock-up of the entire eclipse. We had all the equipment out, we had all the feeds tested, and make sure that everything was working equipment-wise for the eclipse. And so here we have some of my staff standing around at our sun gun, ready for the eclipse. So we went to Charleston, and we arrived that night, and we did some stand-ups there for the news that night, and it was cloudy, and it started to rain. There's the producer looking extremely worried about what's going to happen the next day. There was some talk about moving to Columbia about 2 or 3 in the morning, and so the next day we decided to go onto the site in Charleston. Now, going to Charleston itself, we actually went onto the campus. That's the NASA setup there, the NASA channel, and the problem going there is we lost a full minute of totality, but they couldn't get bandwidth right on the total line, And again, I'd signed on to be their astronomer, so I was with them through thick and thin. Well, it rained that morning. It was still cloudy, but right on cue, as we went into the afternoon, the winds began to blow, and that's our humble setup, and there's the green there, and some of the equipment set up there, the trucks they brought up to broadcast the eclipse back. I'm trying to rush here so I don't let on time. Meanwhile, back at TELUS, this was the line at opening. And so as folks got there, it was a huge party, and the line at the observatory. After about 3,000 people, we stopped counting how many people were on campus. People brought lawn chairs, that people bought. We had it set up in the exhibit hall so they could see the screens as the eclipse progressed. There's me from Charleston in our main theater, so we could interact with the audience, and the audience continued to grow. There's the line a few hours later. The front door is way down there, and so folks continue to arrive. But the interesting thing about this, with 3,000 people on campus, actually about 3,500, there were no complaints. So it was amazing. People brought hammocks, and we're just streaming through here very quickly. The cafe had the largest crowd they'd ever had in a single day. The main parking lot filled, the auxiliary parking lot filled, and it went on into the field. And the sheriff closed the road to the museum, and they were happily towing people at the highway there. And the eclipse continued, and the crowd continued to build. It was just a wonderful day. And you can see the stuff on the ground. And this was the broadcast into the exhibit hall. Again, here in Charleston, as an expert, I had to point out where the sun was there. And it proceeded along in Charleston, and you can see the haze. And so at totality, we did not see the eclipse because it was too thick. We got pretty close, but it was a wonderful experience. And the final chapter is how the media will treat us after this, besides WSB. So I don't know the answer to that. We'll just have to see. Although we had other folks eager to talk to us for the end of the world, and we did have WSB, National Public Radio, do an interview, and then they was allowed because they weren't broadcasting it till after the eclipse, and the title of their story is, "Oh my gosh, I slept through the eclipse." And that was anyway.
Thank you, Dave.
Yes.
All right, and we've got a few minutes for questions.
Okay, so after this eclipse experience, I've said, I'm going to have to prepare better for the April 8th, 2024 eclipse. So in your experience after seeing this, do you feel that your institution will approach the next eclipse in 7 years a little bit more vigorously to prepare for that level of crowd?
I think we were well prepared for the crowds, and our staff was well prepared. I think the only thing that I hadn't predicted was the number of solar glasses, good grief, that we went through. So I would definitely order more. But it was interesting. It's also interesting the amount of the bottom of the pot that gets stirred up with any big astronomical event. So in addition to the people worrying about their pets looking at the eclipse and the normal stuff that you expect, you have the UFO calls, the meteorites in your front yard, and the woman that kept calling me about seeing Jesus in the clouds. So you have all that going on as well.
All right, we've got about 20 seconds.
Sheldon.
Oh, just a comment. After the 1994 eclipse in Peoria, the board was so impressed with the sale of 10,000 eclipse glasses and the burst of $20,000 to the museum budget that year that they asked me to plan another eclipse for the next year.
All right, and that's our time. A round of applause for Dave Dundee, everybody. Okay. All right, so we've got about 2 minutes. We're going to have Gene Bishop up next with the scale of the sun, the earth, and the moon. And so we'll get that started right away. Yes, I think Dave has the clicker. so should probably go get it. Dave Dundee, do you have the clicker? Oh, there it is.
I want to see if it works.
Well, if you're ready, we can start right away.
I guess so.
All right. So next up for our paper session, Jean Bishop of the Westlake Schools Planetarium, scale model of the Earth, Moon, and Sun. Jean, take it away.
Thank you, and good morning, everybody. I'm very happy to be able to share with you something that I did getting ready for the eclipse here in Cleveland, or Westlake, Ohio, where I am. We had 82% coverage, and it was a big deal. It was our first day of school, but getting ready for that, both with the kids and the teachers, and some workshops in the metro parks beforehand, I wanted to devise a model that would explain the true distances to people between the objects of Earth, Moon, and Sun, which are the objects involved in the eclipse. Some points here about models of these. The real diameters and the distance were very important in the eclipse. And it's hard to show both sizes and distances in the same model. How many of you have experienced that? You want to show them, but you know, it's really hard. Textbooks often do a poor job of conveying this, and professional models don't even try, okay? But still, you want to do something. Online activities do not show both diameter and distance or natural satellite because you wouldn't see the really tiny moon. Many people have misconceptions of relative sizes and distances, and without understanding relative sizes and distances, it's hard to know why the moon can cover the sun. You have some teaching to do there. The nature of shadows of the moon and the Earth, they're very different from what people think because they have bad ideas about the sizes of the objects involved. Now, we all know these things. The Earth diameter is about 8,000 miles, Moon about 2,000. The distance between Earth and Moon is about 250,000. Of course, that varies with the elliptical orbit. Sun diameter is about 865,000 miles, or about 1 million miles. And the Earth-Sun distance is about 93 million miles. We start from there. Now, there's a lot of possibilities for making models. And you can do this yourself. It's kind of fun to just wander through stores and look at things that are spherical and round, just in a flat 2D dimension. And you're going to see things like styrofoam balls, pom-poms, tennis balls, baseball, soccer balls, beach balls, ping pong balls, and so on. You can read the list there. I find the little stickers are very good. You can find them in so many different sizes, and coins are good, too. And many of these objects have been used in models you can find in activities that are online. So keep in mind the large sun diameter and the large Earth-Sun distance, and don't make your beginning point in your model of choosing your Earth and the Moon, don't make those objects too large. Select a moon model that you can just barely see, Then select the Earth, about 4 times wider than the Moon. Then select your sun, about 108 times wider than the Earth. Finally, place the modeled objects, which are Moon 30 Earth widths from the Earth and the Sun, Sun about 400 times further than the Moon, about 12,000 Earth widths from the Earth. Okay, so for a scaled model, many people give an estimate of moon diameter that is too large. In Dave Weinrich's talk, he was talking about starting where people are, and I think Gene Creighton brought up this back too. Just start where people are and relate to them, and then go from there. And it's a good idea to ask the people that you're doing this model for, what do you think is the relative size of the Earth and the Moon? And then maybe the Earth and the Sun, and then maybe the Moon and the Sun. But start with their ideas. They usually don't have a good idea. They think, for example, that the Earth and the Moon, that the Moon is bigger relative to the Earth than it actually is. It should be only 1/4 the diameter of the Earth. So here you see some possible combinations that are correct. Mine's at the top. Do you see the little Earth that's labeled with the Post-it note? that's Earth. And moon, you just barely see. Those are BBs. The Earth is 0.44, 44 hundredths of a millimeter in diameter, and the moon is 0.11, 11 hundredths millimeter in diameter. That's what I chose because of the large distance between the Earth-Moon system and the sun. But those other combinations are also correct. Most people would say that you take a baseball and put it beside that larger orange ball to make the moon-Earth relative size. Just try it once with your audience, and so you'll see what happens. Okay, so in addition to those moon-Earth I described, I made a round poster about 45 inches in diameter that I cut from other poster sheets, 4 normal poster sheets. Also bought at the dollar store. I bought a number of things here at the dollar store. The curling ribbon that you see at the end, that was from the dollar store. If you get this curling ribbon, you can find about a 300-foot roll for $1. So I used about a roll and a half here. What I need is 13.6 inches stretched out to show the Earth-Sun distance, and about 142 yards to show the Earth-Moon system to the sun. So there, in a better way, you can see the BBs. Now spray them with something, because you don't want lead. You don't want to touch lead. So you can spray them with clear stuff, as I did, or you can spray them with glow paint. And that's another idea here. Okay, so Earth-Moon diameters, there are 4 moon with the Earth, and you see that in BB, and you see stickers that I found exactly the size of my chosen Earth model. Okay? So there's a moon with a bunch of Earths. Okay, now we're getting the sun in here, the sun poster board. So I started laying out the stickers across that sun so that you're going to be able to see that there are lots of those across the sun, about 108 of them. 13.6 inches or 31 Earth diameters to the moon. That's what this shows. Okay, there's your sun. Now, if you spray that with glow paint, and I did spray my sun with glow paint, that's kind of neat, okay? All right, here's all my curling ribbon. I wanted to have a picture modeling what the thing looks like stretched out. I didn't get that. I only did it 3 times, and every time I did it inside a big room, a very large room. And it's very interesting having people standing at the corners and you're going around with that curling ribbon tape. 426 feet, much longer than anybody would guess. Okay, thank you. Just some relative size ideas and distance ideas to show. Okay, indoors, if you want to use glow paint, a dark area, as I said, I did with the sun. I didn't spray my Earth and my moon, but you could do that, and I may do that in the future, okay? And have a very large area, as big as you can get. Auditorium maybe in a school would do, or if you have an auditorium in your science center, planetarium area, that'd be good. Have a student unroll the distance from the Earth to the sun, and other people will hold up the ribbon as the walking student goes around the corners. It's really fun. It's a fun thing to do, that people get involved. And sometimes you'll hear, wow, or something like that. They don't think of the distance to the sun as being so large. And outside is really, really best. I tried this once and it started to rain, so I really never succeeded. So here's some other model ideas. With sheets of paper, on a computer, scroll down 4 sheets to represent the Earth diameter, down 31 more sheets to give the Earth-Moon distance, 1 sheet for the moon diameter, 12,000 sheets for the sun, 400 sheets for the sun diameter. So in actual sheets of paper, the sun's about 24 reams. Okay. Here's an analogy. Let one normal clap be the diameter of the Earth, and a very fast slap could be the diameter of the Earth. Let's do that. One clap. Another one for the moon. Okay, but now 31 claps to go to the Earth between the moon, or to go to the moon between the Earth and the moon. So we won't do that, but you get the idea. And the sun diameter, okay, here we go, 108 claps. And Earth-sun distance, 124,000 claps. Okay. Light time is another analogy, and it's important to take the time to tell students what's wrong with the model. An accurate model can help erase and prevent misconceptions. It's worth the time. Thank you.
Thank you, Jean. Any questions? Yes.
Can you just scroll back a couple slides so we can get the... They're just great. The one before collapse. That's just fabulous. The analogy with the sheets of paper is great. So thanks for these different ideas, because I think we all do it, but we don't think about
Well, yeah, I think a lot
all
of
these
people
awesome
could do
ways.
it if you know, just put your mind to it. And I actually did discuss this with the teachers, and they said that they'd go back and try it. One teacher got back to me and said she tried this, and it was kind of overwhelming, you know, to do. But I just had really thought them up, and I'm sure that more ideas, analogies could be made. What? One more to the claps? Okay. Are
Jean?
any others of
Yes.
you?
We used to do a Project STAR activity. If you use the 1 centimeter equals 1,000,000 kilometers, you
know.
can set that up in a typical high school hallway.
Yeah.
And the students can draw scales of the planets and their moons, and you line them up in the hallway. So it worked very well.
Good. Yeah. Well, that was tested too. That was a
Yes.
tested program. You can
Yes.
find lots of activities online. This is the one that I decided after looking at it all. You know. Okay. Anybody else? Thanks.
Jean, thank you so much. All right, we're going to get set up for our next paper presentation. That's going to be Radio Astronomy in a Total Solar Eclipse with Christy Whitworth, Gary Lasich, and Lebby Moran.
Thank you.
All right.
The receiver is on this side of the computer, so you kind of need to be over this direction.
Well, from the Pisgah Astronomical Research Institute, if you haven't been to Perry, you really need to go. It's an absolutely beautiful place. Radio Astronomy in a Total Solar Eclipse. Take it away.
So we're bringing a little bit different topic for totality in a solar eclipse. My name is Christy Whitworth. I'm the Director of Learning Experiences at Pisgah Astronomical Research Institute. It's a really long name, so we call it Perry. And this is Lebby Moran, one of our newest science educators. And Gary Lasik is a new volunteer to our campus, and he agreed to help us out since he knew a lot of you folks for some reason. If you haven't been to Perry, we are a radio observatory located in western North Carolina, about 40 miles west of Asheville, North Carolina. And the site has been open for over 50 years in some format, serving space exploration and investigation into, lots of stuff. Our radio dishes are 26 meters across, and we have two of those on our main campus. We have a 12-meter instrument and a 4.6-meter instrument in terms of radio operations, as well as a radio Jove system. So we have lots of radio astronomy working on campus regularly, and we have optical instruments as well. The wonderful thing is that some of our instruments are remotely operated and can be operated by folks at your institutions. If you want to find out more, talk to us. The total solar eclipse passed just over us. We had 1:47 seconds of totality at Perry. And we got very excited about this, and people started wanting to plan. Like, I don't know if you guys know Adam Thans or not, but those folks wanted to start planning with us 2 years before the event. And it was 3. Good job. Because, why was that important? Because we were going to be the first radio observatory in the path of totality in the 80 years that we've been doing radio astronomy here on Earth. Yeah, that was I think you get it now. That was the part that gave us the goosebumps. So we invited about 1,000 of our closest friends, including Adam. And we had events going on all over campus. This is the largest event that, as Perry, in the almost 20 years we've been Perry, that we have ever hosted on our campus. We are a very small staff. We are up from 12 to 15 staff members now. And the folks really wanted to immerse themselves in a total solar eclipse experience that was a visual experience. We also had suffered the same fate as Charleston, so I won't go into it because it's still traumatic. But radio telescopes don't care about clouds. This leads us to our next section.
So it was a little traumatic for Christy, but I can say the words. We had a cloud right at totality. It was completely clear leading up to it. A small thunderstorm started moving through, and exactly at our 1:47, it was right in front of the sun. It wanted to see it too. But luckily, our dishes were able to see it, even if we weren't. So the two that we used were one of our 26-meter, and then the 12 is the smaller one on the other side. Both of the 26-meter dishes are right in the public eye, so that's one of the more astounding things when you drive onto campus. You see this 100-foot tall, 80-foot across thing. The 12-meter is a little bit farther away, since that's the one we normally use for education, and we don't want to have anyone accidentally run into it with their car or something. But both of them were turned on and watching for hydrogen alpha in the corona. We pretty much watch right along the neutral hydrogen line, right around 1420 megahertz. And we were hoping to agree with this study back here. And luckily, it is looking like we did. So these top two are from the 12-meter. The bottom is from the 26. The first one on this side is right before totality. I think it was about an hour and a half or so. Yeah, first contact about an hour and a half before totality. These ones over here were during totality, and what we were looking at is for that little tiny bump right there. And so luckily we got it, and we were all really, really excited about that. We are still working right now on the analysis of it. We have to make sure that nothing, say, behind the sun and moon was causing that bump, either man-made or something else in space, because it was technically right in Leo, and Rigel is right there. We needed to make sure that nothing around that was causing our little bump, but we're still going through and doing this. And that will go. So that's Smiley. That's our little 4.6, and he's kind of our mascot, but this goes to the next part.
Thank you, Lebby. Obviously, this all factors into our education and public outreach, and that's one of the unique features about Perry, that they are very strong both on the research side and the education and public outreach side. We regularly observe the sun with radio telescopes on campus, and if the public comes through, they can even be trained into how to operate the radio telescopes here. Now, the more ways you look at something, the more information you get. That's why astronomers observe through the whole electromagnetic spectrum. So when we can combine data like this with the visual observations, then the public begins to understand how much information we can gather once they know what they're observing. As Lebby mentioned, we're still going through the data reduction so that we can come up with what the actual corrected observation was. This is, again, the first time that a solar eclipse path has passed across a radio telescope. We did manage to get a couple of images through the radio telescopes. I should mention too, these are some maps of radio emission in the sky. We're still working on getting a way of superimposing those on our planetarium sky so that we can go from one to the other. But we're looking forward to having that. As I mentioned, we do have a couple of images of what the radio telescopes showed. This is before the eclipse, and this is totality. Thank you very much.
Well, thanks to all of you. And so, since we came in a little short on the time there, we've got about 4 minutes for questions. So if you want to know much more, all right. And then get back to you, Mel.
I'm so old-fashioned. I'm having trouble understanding what the frequencies mean in wavelengths. And I thought I heard you mention in the first third about H-alpha. Is that visible in the radio?
It was neutral hydrogen is the observation that we made. 1,420 megahertz or 1.4 gigahertz is our central observing frequency, and our spectrometer detects dips and troughs. That graph that you saw, the ups and downs, tell us whether there's emission, intense emission or lower intensity emission, and we were watching that graph. The length of the wave that we detect is 21 centimeters long. Yeah, it's 21 centimeters long. And Mel had a question. Mel is an affiliate of Perry. He actually worked at Perry over 10 years ago. He was there when I started, and is someone who's been an advocate for us all these years.
Yeah, this is going to sound like a planted question.
He doesn't know it.
After that introduction, I wasn't going to say that I had any. I was going to ask you to say a little bit more about your teacher training programs where they can get to use Smiley.
So we offer, we can do this remotely or in person. I think you might prefer it in person based on your backgrounds. But if you do a remote, even remotely, we train you to use the 12-meter and Smiley. You learn to drive the instrument. You decide where to point the instrument, which objects to observe. You make your observations, and then you learn to analyze those observations to help you learn about the motion of objects in our galaxy and primarily in our galaxy. And then for our sun, you can detect things like solar bursts, and the same way you can with Radio Jove. Radio Jove is another counterpart, but both of the remotely operated radio telescopes are fully determined by the user in terms of where they point and what kinds of observations they make. We also do mapping scans with those instruments, which means you use that telescope as a 1-pixel camera and map the intensity to the location on the sky and build your own image, color by number.
To complement that, we also have a remotely operated optical telescope, and we're one of the darkest sites in North Carolina, so you can do that too.
I'm wondering if there were any other radio telescopes out in this eclipse. There weren't any working prior to you, but were there some that concurrently were trying to get observations at the eclipse this summer?
I am aware of Radio Jove doing concurrent observations at multiple locations in totality and partiality to help with similar types of observation. Their observation is at a different frequency. It's a 20.1 megahertz with their systems using dipole antennas. Those are a much more mobile system, and there were a lot of places, Mexico and in Mexico and the U.S. that were participating in that.
Thanks.
We still have time for some more questions. Any more questions? All right, Adam. Of course, Adam.
Hi. Question about the accuracy in relation to the size of the sun or moon with the radio telescopes? Because you were saying you're not sure where exactly. So do you have like it's this big in relation to the sun or moon for their accuracy?
So why do you guys like telescopes that have bigger diameters? More light for a smaller aperture, a smaller area of the sky. So the big telescope only observes about 1/2 degree, the diameter of the sun. The 12 meter is a smaller telescope and observes a little bit over a degree and has included the corona. So so what we were working toward is actually a subtraction of the two graphs that you saw to lead us to whether or not there's a detection of neutral hydrogen in the 12 meter observation or not. But we have to get those two calibrated together and verify that there's not another source in that space.
All right, we're actually going to have to cut that off, but, well, actually, you've got about 15 seconds.
Okay, I can do that. We're planning to run Bays Mountain Totality in our planetarium, in addition to what we're doing locally. So we'll be able to have a look at both of those.
All right. Round of applause for Christy, Libby, and Gary. Thank you, guys. All right, next up is going to be Christine Shupla. We'll get all that set up and get going in about 2 minutes. All right, our next paper this morning is going to be Christine Shupla from the Institution of Lunar and Planetary Institute. Lunar and Planetary Institute, there's, I guess, a typo in here. This is activities for engaging audiences in planetary science.
Hi, everyone. All right. I wanted to share a few different ideas for activities. Now, some of these will be ones familiar to you, of course, and most of them aren't original to us. Taken things and revalued them, made changes to them, modified them. Not a huge number of new activities under the sun. So LPI, about LPI, Paul talked a little bit about it this morning. We're a research institute in Houston. We did not flood, thank you. And we're delighted to share planetary science with you all and hopefully give you some ways to continue doing that with your audiences. The main thing I'm going to be sharing is part of our Explore program. Explore is an LPI program, was originally created for libraries, but frankly, all of the activities are great for out-of-school time. And we do have, for those of you who are in schools, I have another website that has lots of classroom activities, mostly for middle school, with focus on phases, seasons, plate tectonics, as well as space exploration. So just about Explore. Explore has a lot of hands-on, simple, easy activities. Those of you who are covering Juno, the Juno mission going around Jupiter right now, we created this module for the Juno mission. It's called Explore Jupiter's Family Secrets. But talking about Jupiter by itself doesn't give you context. So this is in the context of the solar system, comparing Jupiter to other planets in the solar system. Things like the mass, the weather, scale, distance, magnetic field. And these activities are geared for younger audiences for the most part. The magnetic field ones, very, very simple, very, very young elementary age activities. Couple of examples, just 3. There's actually more than a dozen, almost 2 dozen in that set. But heavyweight champion Jupiter, you get to weigh yourself. Storms is one of the ones about weather. There's a whole set of ones about weather. And again, these are pretty simple activities, investigating the inside. So let me tell you just a tiny bit. How many of you already have scales where your visitors can weigh themselves on different planets? If you don't and you want to, just go to Walmart, buy scales, take the top off, make sure they're analog scales, not digital. White out the old numbers, write in the new numbers. It's really easy to do, and voila, you have the ability for your guests to weigh how much they weigh on Jupiter or Mars. You obviously have to pick one unit or another. We picked pounds. I did have some confusion with some visitors from Japan who wanted to know why this was so wrong because they were used to thinking in kilograms. So, of course, you could do both. You could have a set of scales in pounds and a set of scales in kilograms. You can, now this particular activity, you can extend the science, bring it up to much higher levels, have them talk about the features of the object, and try to determine what it is that causes the gravity to be that much. Give them information. We have a full write-up. Give them the information about the atmosphere, about the distance from the sun, about the mass, about the density, and let them start to draw their own conclusions about the relationship between weight on different planets and mass and density. Storms, very low level one here. If you want to simulate in a very cheap and easy manner storms, we just used water and cornstarch, and we'd sprinkled a little bit of something like crystallite, a diet, doesn't have to be diet, something with color in it on top. And as you run the spoon through, slowly, through the cornstarch at the bottom that's going to settle out at the bottom, you're going to generate clouds, storms, and let it settle again and repeat. And you can do it over and over and over again. So you can use it simply talking about models, the limitations of models, and which way this is a model of a storm, and which ways this fails, or the limitations of this model. We have other activities for weather stations, very, very simple things about cloud observations, tornadoes, how wind forms. You can fly a little tinfoil kite over a toaster, and as the heat is rising, you can see how it's generating wind. My favorite one there for the upper level is the relationship between temperature and pressure, using a fizz keeper and a bottle and a temperature, an aquarium thermometer inside of the bottle, and that aquarium thermometer will change as you pump, as you add pressure to the bottle. Investigating the insides, well, how is Juno understanding what's going on in Jupiter? How is it studying this planet? It's inferring things. And so you can talk about observations and inferences. This is one of my favorites. It used to be able to use a single balloon. However, they no longer make balloons that you can't see through. So I've become an expert in double ballooning balloons, where you stuff one inside the other, and then you stuff the inside one with whatever you want, paper clips, BBs, beads, marbles, different assorted materials. Then you inflate the inner one, tie it off, inflate the outer one, tie it off. Sometimes we add water. Be careful if you add water, particularly if you add a magnet with the water and somebody's investigating it with another magnet. They might pop. If your planet they're not allowed to pop their planets. Planetary scientists can't investigate what's going on inside of a planet by popping their planets. However, sometimes one pops by accident while they're investigating the magnetic field of their planet. And we have a perfect analogy. It's called meteorites, right? We've got popped planets all over the place, little pieces of asteroids that have been destroyed. So, again, analogies, you're talking about how they're using the mass, the weight, the temperature, if you decide to take it and freeze it or something, to start to infer what's on the inside, how they can see how the mass is distributed as they shake it, what sounds it makes. The missions that are orbiting planets that are studying the interior dynamics are doing something very similar. They're studying how the mass is distributed. They're just studying a little bit about the weight and the composition to help infer what the layers are like inside. Explore Health in Space is a completely different module. It has lots of activities. Two of my favorites, UV Kid and Measure Up. UV Kid, they're using pipe cleaners, beads, and UV beads, not just to go see if it changes color. Of course it's going to change color. They knew that in advance. We want them to make a hypothesis about what will protect UV Kid and then test that hypothesis. We provide materials, construction paper, saran wrap, sunblock, different materials, have them design something to protect UV Kid. It can be a rocket. It doesn't have to be a kid. It can be a butterfly or an alien. And then design the costume, test UV Kid to make sure that it changes first before they design the costume, then design the costume. generate their hypothesis. Is this going to work well? Do I think blue saran wrap is going to work really well? Not very well in comparison to construction paper. You know what? I think it's going to work really well. No, it didn't. You know, things like that. Measure up. You probably have seen a different version. This has been around for a long time. You lie on the floor, you stick your feet in the air, you measure your ankles before and afterwards and see how your fluids have changed. But there's a whole lot of activities in this module about training the astronauts in space and the health in space. Marvel Moon, there's a lot of activities in Marvel Moon, more than a dozen. One of my favorites is, let me go back one. Many of you have probably done the impact craters with the marbles and the flour. In addition to that, I wanted something that would teach that the impactor, the asteroid, doesn't just sit there, it's destroyed. Water balloons, awesome. So water balloon not only demonstrates that it's being destroyed, but also the analogy in the impact box, you usually have a crater the same size as that marble you just dropped there. This one, your crater is much bigger. Have them measure the ratio of the balloon to the crater. That's similar to the ratio of an impact crater to the original impactor. It's similar. You want it to be between 1 to 10 and 1 to 20. So we've got other modules as well. We've got a couple about Mars inside and on the outside and life on Mars. We have a Facebook group where I post things, opportunities, new materials, ideas. And I wanted to share, we have traveling exhibits. I've got flyers for these in the back next to the water. They're available for free, except for the cost of shipping. If you provide your own FedEx label, then we will ship it to you for free. And we've got more than half a dozen of them, different related to lunar and asteroid science. And there's lots of other NASA sites that have great activities too. NASA Wavelength, of course. NICE Network is handing out free Earth and Space Science kits. The application deadline is November 1st. I have their flyers in the back as well. And of course, Solar System Exploration is a great site with lots of information as well as activities. So, I don't know, do I have any time for activities and questions? Okay.
Any questions? Any questions?
I don't have a question, Christine. Thank you, first of all. Great. But I do something with pop cans, and other people might do this too, because I don't think it was original with me. But I put different things in pop cans and have students heft those, because each one is prepared to be what that can of pop would be like on a specific planet.
We have a version of that.
Yeah, okay.
Yes, we have a version of that with beans. It's called Beans in Space. And
Well,
it's one of the,
the kinesthetic thing, rather than just looking at a number on a scales, I think is really effective. I like it.
Awesome, yes. How much a different can would weigh on different planets, whether it's pennies and soda cans or, the version that one of my colleagues came up with it's called Beans in Space, and it's how many beans in a can,
All right. Any additional questions, comments? All right. Well, Christine, thank you so much. And then in just a few minutes, our final paper presentation of the afternoon, Sheldon Schaefer, Bradley University, talking about macular degeneration and appreciating the total solar eclipse.
Okay. And it looks to me like we're early, so we should wait in case somebody's coming from the other session. But unrelated to my paper, just an announcement of sorts. I'm one of the trustees for the Hamilton Planetarium Scholarship Fund. We have some $10,000 to $12,000 a year to give away to students who hope to pursue a career in planetariums. So applications are online. I also set some flyers out on the table next to the IPS poster, on the table right outside the door. So if you are a student or you have students who hope to pursue a career, they can apply for usually in chunks of $2,000 to $3,000 per semester for the scholarships. So now I'll wait until the appointed time, right? 20 seconds.
All right, and for our final paper presentation of the afternoon, Sheldon Schaefer, Bradley University, The Effect of Macular Degeneration on Appreciation of the Total Eclipse.
Okay, so first of all, macular degeneration. If you're not familiar with it, it's a degenerative condition affecting the central part of the retina, the macula, and results in distortion or loss of central vision. So some of the diagrams showing the drusen that appear on the back of the retina and what a person with macular degeneration will see. Right now it affects about 1.75 million inhabitants of the United States alone, and because of the aging of our population, by 2020 it'll be about 3 million people will be affected by macular degeneration. And as an eclipse chaser, I'm somewhat interested in this because I've been diagnosed with macular degeneration. And it has not affected my vision yet at all. It may never. It doesn't necessarily progress to the stage that you see in the fourth field there, but it certainly could. The subject of this paper is a 77-year-old woman who has moderately advanced macular degeneration. It's advanced from the dry to the wet stages, more severe, somewhat treatable at that point, but only to arrest the further development and not to ever regress it. And she was first diagnosed 10 years ago, and as such, she's lost her central vision. And as I understand it, it's probably a little bit worse than you see in that picture there. And as early as this past January, I was discussing with her the upcoming eclipse, and she had no intention to go to it because it was her thought that with her condition, she wouldn't be able to enjoy it or experience it at all. But I talked her into going, and she agreed to travel to Totality and report on her experience. And since she would be going on her own with her own family on Eclipse Day, and I was going to western Nebraska, and she was going probably to Missouri, I prepped her. One of many checklists for observing, nothing new in here, but what to look for as the partial stages progress, what to look for during totality, and just sort of some highlights. So we went over that list before she went, several weeks before, and she was going to record her experiences, and then on Eclipse Day, I was off to South Dakota and western Nebraska, and she went to staged in Des Moines, Iowa, actually intending to go where it looked like it would be most clear. And then after we returned, we met to debrief, and she followed up with an email and written comments. And so as reported by her, it was a really rainy day, and they were able to find a clearing in the clouds and stop there. They saw the entire eclipse from the parking lot of a propane dealership in the middle of a cornfield. So they had great viewing conditions. There were other people there as well. She reports meeting people from Nebraska, Iowa, Virginia, Minnesota, and Illinois in this town near Lathrop, Missouri, actually. Everyone was very friendly, and they took pictures of everybody and all the other groups. They did have totality. They reported actually seeing a corona after the eclipse. She was not able to see the Bailey's beads or the diamond ring, but at least they had a corona. She also reports seeing a completely clear horizon. She could see the sky, the sunset effects, the colors of the sky and the sunset. She was aware of the activity. She particularly noted the birds and the locusts, And what they were doing that was unusual or odd for that particular time of the day, everyone but her saw the fireworks in the distance that were set off during the eclipse, so she did miss the fireworks. She also noted, I thought of how ancient peoples thought of an eclipse. I'm glad that no one wanted to practice human sacrifice, as I could really see how they would respond that way. She had a good time. So, in a quick summary, that she was exceedingly glad she had the opportunity to experience the eclipse, even if she was unable to see the actual corona. She was able to share in all the social aspects of the eclipse, which were numerous, and maybe sometimes we discount that element of the eclipse. She was able to see the changes in the sky, in nature, and in her surroundings. And she was actually able to see the partial stages of the eclipse through the eclipse glasses you can position, you have the time to position the image. And I was surprised at that. I did not think she would see the partial stages at all, because that really goes right to the central part of the macula. But with proper time, she was able to adjust that to the side of her vision. But the corona itself, the Bailey's beads, the totality was not bright enough to see, or there was not time enough to position them to functioning parts of her macula. So she didn't see that. And she didn't report seeing any of the planets or the stars. I was not surprised at that, because it was so quick, I didn't see but Venus, I think. So that wasn't surprising at all. So I'd say it could be concluded that she was able to greatly appreciate the event, and despite being unable to see corona in totality, but of course some of you didn't see the corona at the moment of totality also, and still appreciated the event. So if you do have the condition or know people with the macular degeneration, certainly encourage them to experience the eclipses. There's a lot more there than meets the eye.
Thank you, Sheldon. Any questions? Yes.
From the picture you have of the last stage that she has, can she see anything just by turning her head and then catching the image in her peripheral vision? I mean, could she have seen some of that if she just turned her head and
Well, and that's what I thought, but of course, it also depends on the brightness and the ability to work it around, and she was able to do that, surprising to me, with the partial stages. But for whatever reason, she wasn't able to do it with the corona. So yeah, she does see something, and you can use on an iPhone or an iPad or other electronic devices, you can use some visual aids to help you read as well. It's not easy. Mostly she does audiobooks. She can't drive. But yeah, you do have some peripheral vision. It varies by the degree and the size of the macular degeneration, how much of the field is missing.
Hi, I'm sitting right next to you. I'm Morgan. I have Stargardt's disease, which is a form of macular degeneration. So I can answer your question much more directly. And the answer is yeah, absolutely. So if I look straight at you right now, your whole face disappears. Looks like just a skin-colored blob. But if you hold up a couple of fingers, like the two you just held up to me, if I don't look right at you and I look, say, at him, I can see exactly how many fingers you're holding up. So it depends person to person, of course, depending on how it presents. But yeah, it took a long time for me to realize I had problems, because I had learned about telescope observing using averted vision, and just naturally did that for many years before realizing there was even a problem. Yeah, just not directly. Anywhere else. Yeah, if I look straight at you, it's just a big blurry blob. But anywhere else, I can see your fingers, etc., in perfect detail. It's called Stargardt's disease. It's a childhood form of macular degeneration.
Any other questions?
I'd be curious for the results of this experiment with a lunar eclipse, and there's one coming up, I think, in a little while. Any plans to try anything with those?
I might talk to her, see what she says. Yeah.
All right. Any other questions or comments? All right, Sheldon, thank you so much. And that is going to conclude our paper session 2A this afternoon.